Hi, my name is Darshan and I'm an online tutor of math and physics. In this video, we're going to introduce the semilog plots, which is a very new and an important topic for the brand new AP Precalculus course issued by the College Board. This so-called tutorial will be divided into three parts. This is part one of it, where we're going to introduce what that is, plot a little bit of somewhat points, and part two and part three eventually we're going to move ahead. So there are, in general, when we want to talk about semilog plots, we have three kinds of plots, right? First one, we are very familiar with what kind of plot that is. This is obviously a linear plot, right? This is a linear plot. Why is this a linear plot? Because as you can see, x and y axes are scaled linearly, like the distance between 0 to 1 and 1 to 2 unit is same likewise 2 to 3, 3 to 4, 4 to 5. So it's equally spaced. That's a better word which I can use. That is for x as well as for y axis. We have been using this all along, so we are very well aware that this is a linear plot. Now, what was the other kind of plot which looks like? What is this? This is a log plot. Log plot. What is the meaning of log plot? Obviously, you can see that the x and y axis are no longer linearly spaced or equally spaced. They are spaced with some uneven distances, right? They are spaced with some uneven vertical lines and horizontal lines. What are they? Actually, each of these point over here on the x and on the y axis, that's why it's called a log, because that's x and y axes both are not linearly scaled, they are logarithmically scaled. So when I plot a point over here, for example, if I want to mark what this point is, what the starting point is, that will not be 0. That will actually be 1. Because if I want to take the actual value of it, this is actually log 1, and log 1 is 0, which adds up with our linear scale, because linear scale starts with an origin. Likewise, what is the next point? The next point will be a 10, because log of 10 is 1, which definitely adds up once again with my linear scale, and so on and so forth. This will be 100, this will be 1000, and so on and so forth on the x and on the y axis as well. So since both the axes are logarithmically scaled, that's why it is called a log plot, because both are in the logarithmic range, so this makes sense. And the next one is the semilog plot, where, as the name suggests, semilog would imply that only one of the axes is being logarithmically scaled and the other axis is just linearly scaled. It can be an x-axis, it can be a y-axis as well, which is logarithmically scaled, but most likely, potentially, AP Precalculus is gonna grill you on the y-axis being logarithmically scaled. So that's why I'm just taking that, sort of graph over here. But just keep in mind, semilog means any of the axes can be in the logarithmic fashion. So as you can clearly see, the x-axis is linearly or equally spaced 10, 20, 30, 40, 50. However, each block over here, so-called, is logarithmically scaled with uneven spacing, starting from 1, just like I told you in the previous slide, going from 10, 100, 1000, 10,000, and so on. Right? So this is what semilog plot is. Why is semilog plot important? I will cover that in part 2. But the last part of this video, the last so-called message which I want to give from this video is, let's try to plot some points on the semilog curve over here. So they are saying that plot the following points on the same coordinate plane above. Now, I want to make this very clear. Some of my students are very confused. Okay, 0 to 200 means that on a semilog plot, if I want to plot it, I have to take a log of 200 and then plot it. Absolutely not. Remember, semilog has already done that work for you. They have already taken the logs of all the values and then scaled it, so that you don't have to worry about taking the log additionally. So all you have to do, for example, I have to plot 0, 200, is look at the 0, which is obviously over here, and 200 is just the regular 200, the way you count it. Now, how do you count it? This will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now the counting will start from 10, but it will go to not 11, 20. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Then it will again change the scale. 100, 200, 300, 400, 500, 600, continue till 1000. That's how we read a semi-log plot. So if I want to graph it, I think that would be intuitive now. 0 to 100 would be what? Here, right? Because that is 0, that is 200. So this is point A. Where is 125? 1 is right here, and 25 will be, I think this is 10, this is 20. So somewhere in the middle is going to be 25. This is point number B. 27, where is 27? 2 is right here. 7 will be 1, 2, 3, 4, 5, 6, 7. It's hard to read, but I think you understand, right? That's like 1, 2, and 3. That's right over here, right over here. That's point C, the 7th line from the bottom, if you understand. 3.2 comma 800. Where is 3.2? I think this is 3, so this is 3.2, 3.4, 3.6, 3.8, and 4. So this is 3.2, and 800 is going to be obviously the 8th line over here. That's going to be 100, 200, 300, 400, 500, 600, 700, and 800. I know it's hard to read, but I think you again understand what the message is. So this will be D. I'm just gonna erase this over here. Just gonna place a dotted line so that we understand it corresponds to 3.2. Finally, 4.6, 1.5, 4.6 is 4.2, 4, and 6. 4.6 is here, and 1.5 will be right in the middle, because this is 1 and this is 2. So 1.5 will exactly be in the middle. So this is point number E. So I hope the introduction of the semi-logs makes sense, but don't worry, this is not the end. In the next video, we're going to talk about how to, what is the benefit of semi-log vis-a-vis AP Precalculus, and how to convert an equation, a function, into a semi-logarithmic equation. So I'll see you in the next video. Bye-bye.